Okay, once again, a very, very good evening, ladies and gentlemen. Welcome to the December monthly technical meeting organized by the Society of Petroleum Engineers Abuja section. Of course, SPE Abuja is known as the section that champions excellence. And of course, we've brought this befitting themed TL to you. Of course, the theme is the application of AIOT. May ask what AIOT means: artificial intelligence of things, application of artificial intelligence of things in the petroleum value chain. Of course, today we are so pleased to have Dr. Agu Collins Agu, who is the founder and chief technology officer of TD4 PIA Tech Hub Nigeria, who would be doing justice for today's theme. I'm going to continue the event by giving a few announcements. And of course, I'll start by kindly appealing that please, for the course of this event, if you're not speaking, you leave your microphone on mute. And of course, you turn off your video cameras. We'd like to have all focus on the lecturer who will be speaking to us today. I'll continue the event by sharing the agenda for today. This event is built to last for 1 hour, of course, 30 minutes. We will start with the safety brief. After the safety brief, we would introduce a few of our speakers and dignitaries have joined us. And after that, we would have a remark by our section chairman, and then we bring in the speaker. After the speaker is done speaking, the speaker would be giving us a lecture for about 35 minutes. And after the speaker is done for about 15 minutes, we would have time to respond to your questions. And once it's done with responding to your questions, we'll have a closing remarks by our assistant programs chair, and then we call it a day. On behalf of SP Abuja section, we'd like to say warm welcome to every distinguished personality that have joined. Of course, the safety brief is on your screen. The safety brief is on your screen. We ask that you mute your mic, raise your hands if you want to speak, and of course, use the chat buttons, C and Q, comments, questions, and of course, ensure you can hear the fire alarm with your headset. And of course, the last but not the least, please be at alert and aware of your environment. Of course, we continue this event by recognizing some amazing people that have joined us from all parts of Abuja. We start by saying a warm welcome to our section chair, Engineer Ikechukwu Okafor, PhD. Well, welcome to you, section chair. Confirm you can hear me, sir.
Yeah, thank you, Akpan. I can hear you.
Oh, thank you, sir. Welcome, and thank you for being
loud and clear.
Yeah, thank you, sir. We also say a warm welcome to our membership chair here present, Dr. Ogenerume Ogolo. Welcome, membership chair, sir. Membership chair, confirm you can hear me.
No, this is the password. That's a place.
Okay. We can hear you, sir. We welcome our assistant programs chair on the call, Dr. Malami Mohammed. Welcome, Dr. Malami. Nice to have you here, sir.
Good to have you here, sir. Good evening.
Yeah, very good evening to you, sir. We are pleased to have the founder and chief technology officer of TD4P AI Tech Hub Nigeria, and of course, the pioneer director of research and development of NITDA. Welcome, Dr. Agu Collins. Agu, welcome, sir. Confirm you can hear me, sir. Our speaker, confirm you can hear me, sir. Okay. While we believe our speaker probably is trying to unmute his mic, we would like to welcome all of our student members from all of our chapters. We kindly appeal student members, you rename your device correctly. Let's have your name and then the name of your university after your name. Welcome all students chapters from our 9 universities. Welcome and welcome. Of course, welcome all of our senior members present in the call. We believe you would have an engaging lecture today. Of course, Your Excellencies, ladies and gentlemen, we're going to switch gears immediately by listening to our section chair. Of course, it's going to give us a welcome address. Please help me welcome our section chairman, Dr. Ikechukwu Okafor, for his address. Section chair, sir, the stage is yours. Hello? Am I being heard?
Can you hear me?
Your network is cracking, sir, but we are hearing you, sir.
Yeah, yeah, my network is a little bit poor.
Okay, sir. So you can continue. It's coming and going. You can continue.
My network on my laptop just zapped out, so I'm on my phone. It is welcome at this. Good evening. A warm welcome to everyone on this call.
Hello, section chair, sir. Okay.
Can you hear me?
Okay, I'm hearing you now, sir. You can go ahead, sir.
Okay. My internet has not stable, but I hope it allows me to complete my welcome address. Good evening, everybody. It's a pleasure once again to gather together with distinguished members of SP Abuja section. Good evening to our dear resource person. It's a great pleasure to have you speak to us today on this all impacted theme and topic. It is no news that the times are changing, and those who would succeed are not necessarily those who are stronger. They are actually those who are aligned with the changes as they come, who learn the ropes as they come. SP Abuja does that one thing very well, which is the promotion of excellence through sharing of technical knowledge. And one of those platforms is our monthly technical meeting, where we have distinguished resource persons speak to us on topical issues like this one we want to meet into today. On the call, we have senior professionals, we have young professionals, and of course, I'm seeing a good number of my students who have joined this call. It is a welcome development. I want all of us to pay attention in the next 45 minutes so we make valuable, we get valuable things from our speakers that changes our perspective and that puts us on an advantage as we continue with these topical changes in and around the oil and gas industry. The value chain of the oil and gas industry is quite critical, and if we begin to learn the Internet of Things around it, it is even more so important. So it is a pleasure for me to welcome everyone to the December multi-technical meeting of the Society of Petroleum Engineers Abuja chapter. Thank you once again for joining. Good evening.
Thank you so much, Section Chair, for that very short and brief yet incisive welcome remarks. Ladies and gentlemen, right now, we are about to get into the business of the day, application of artificial intelligence of things in the petroleum value chain. Of course, today we are going to be taking a presentation which explores the application of AIOT in the upstream, the midstream, and the downstream segments with emphasis on emission and environmental monitoring, early warning systems for oil spills, and adherence to environmental standards. The very next slide you'll be seeing would be telling you about who would take this amazing theme. Of course, Dr. Collins Agu comes readily as a technocrat, that individual with technical training and occupation driven by the belief that many important societal problems are solvable with the applied use of technology and related applications. Of course, he is the pioneer director, research and development of NITDA. Of course, essentially a researcher and a tech native committed to building young people into techies. The passion he has fully expressed in the various hubs he has inspired into existence and the people he has mentored to keep pushing the frontier of tech research. Of course, he started as the first hardware hub in northern Nigeria to promote upstream ICT. TD4PAI has helped to bring costly premium digital skills to young people and at no cost to them. Of course, he has a very, very long profile. If you go on and on in reading them, let me just go to the next slide so you can have a look at who you'll be listening to. He is a technical mentor at Innovate Hub, where he's helping to facilitate capacity and prototype development for the Unity board for the startups at the hub. He holds a top-level doctorate degree in engineering sciences from National Technical University at Harvard University in Ukraine. And of course, his PhD dissertation yielded an invention, a hydrocarbon-based solid substance for combined processing for materials using electroconductive abrasive tools under the Ukraine patent. Of course, since 2011, through various work experiences with government and private concerns, he has become an iconic proponent of open source technology, indigenization, and adaptation of technology. Like I said, I could go on and on. Let's keep to his awards. He has a Merit Award for Excellence in Technology Development, and he is in Nigeria. He is in Nigeria Diaspora Global Hall of Fame. Of course, he has aspiration to build more young people into techies that will advance development of the African continent. The engineer and researcher has long found his calling in engineering the lives of young and talented people to find meaning in technology for development and, most importantly, for the eradication of poverty. Ladies and gentlemen, please help me welcome the founder and chief technology officer of TD4PAI, Tech Hub Nigeria. And of course, he doubles as the pioneer director of research and development of NITDA. Help me welcome Dr. Agu Collins. Agu. Welcome to you, sir. Can you hear me once again?
Hello, good evening, everybody. Can you hear me?
Loud and clear. Loud and clear, sir.
Can hear me. Okay, thank you for having me. And thank you for the wonderful introduction. We just having some technical challenges joining the meeting, but finally we managed to join now. I'm actually speaking from the TD4PAI Hard Tech Hub here in Kuje. So please permit me to share my screen if you don't want, so I could start the presentation.
Yes, sir. You can share your screen, sir.
Which of them am I sharing here? 2 seconds. 2 seconds. I'm sharing this one. Let me put a slideshow. Okay, so where's the Zoom?
Just confirm that they can see your screen.
They cannot see my screen either. Can you see my screen? Hello?
Not yet.
Man, this is a bit sorry, I think this is here. Sure. Can you see my screen?
Yes, yes, sir.
Yes, yes.
So, okay, thank you very much. 2 seconds. Okay, thank you. So before I start, you may want to scan the QR code to get more details about me. And then some of you may want to follow me on my social media handles because we do a lot with respect to Internet of Things and artificial intelligence of things. And we all know that Internet of Things is one of the pillars of the fourth industrial revolution. And why it is so important is that today we talk about AI, and one of the trust or drivers of AI is what they call data sets, reliable and robust data sets. So the big question is that how do you acquire reliable data sets to feed into an AI system to give you a positive output? That is where the Internet of Things comes in as a data acquisition platform. So I will make a little bit of introduction of the Hard Tech Hub located here in Kuje. If you talk about an ICT engine room, the TD for Pi is actually an ICT engine room where we carry out startup incubation. We also carry out training, and most importantly, we carry out a field application of technology in solving our numerous problems, applying indigenous technology for sustainability. So you may wish to scan also the QR code. We'll see some of the visitation with quite a number of people. Then I would like to mention about our product. One unique thing about TD4Pi Hub is we believe in the indigenization of technology and also adaptation of technology for sustainability. So what you're seeing on screen is some of our products. We are very strong in upstream ICT, embedded system programming, using various microcontrollers, PIC Micro, AtMega, up to FPGA and so on and so forth. We'll also do some of the drone designs in the past. Arduino board model after Arduino as well. No, so many. This is just a few. Amadio IoT engine as well. We're talking about artificial intelligence of things with respect to value stream for petroleum industry. The underlying technology starts from things like embedded programming, chip design, and even up to the PCB design and manufacture. Today we talk about various technology. We talk about cybersecurity. We talk about AI, especially, and also IoT. We'll have to understand from where we got all this from. Recall that in 1948, Bell Lab discovered the transistor. Because technology adaptation is key, and it is a long-term policy where we basically have to consume what we produce and produce what we consume. Now, to break this very presentation for everybody to understand, because I understand that most of us may not be too techy, I will start first of all by playing a small video about the applications of IoT happening here in Kuje at the TD4Pi Hard Tech Hub, where we displayed remote monitoring of reservoirs. If you're talking of petroleum value chain, you have the upstream, downstream, midstream, and of these streams involve storage, involves transportation, and so on and so forth. So here we're demonstrating a storage / also transportation. I should be able to monitor my petroleum product as a moving point from point A to point B. And I should also know if I'm offloading product from a jetty, I should know how much is being offloaded. And then if I have a supply brought in, I should be able to know how much that is supplied without having to be there. Absolutely. So I'll demo this very fast. And because of time, I may not be able to play the video to the end. So just listen carefully. Thank you. So we're using water here in place of fluid. We're using water here in place of diesel, LPG, or even crude oil. Thank you very much. I'm trying to play now. Wait. That's the water. It's how I've opened up. And monitoring how water is. And then this is the data acquisition platform. The solar panel.
Wow, it seems the network of our speaker is not really good. Confirm you can hear me, please. Please confirm you can hear me.
I can hear you.
Oh. I'm so sorry about this. 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 Okay, so we'll try to see how our speaker can come back, probably with a better network. But for now, let's make use of the chat box. Where are our techies in the house? What can you say about artificial intelligence of things, and how do you think this can help the energy sector to probably combat gas flaring and all of that? I would like to read your comments. I'd like to read your comments on AI of things. Let's know what you've got to say.
Or the process.
Okay, he's back.
That's where the hardware comes. Sorry? Can you hear me? I'm hearing some voices. Am I good to go? Hello? They're not hearing me. Hello?
Yeah, your voice is cracking.
Can you hear me?
Yeah, it's cracking, but we are hearing you.
I don't think these people are hearing me. It's terrible.
I can hear you, but if it's cracking, you are going up and on, but we could
so
hear
can
you.
Hear me? So what do I do now? Let me see if I can switch off the. Let me switch off the camera. Oh, it's better now. I don't know. I don't know what's going on. Can you hear me, anybody? Can you hear me? Dizzy.
Yes, sir. Can hear you.
Where's it? Where's it? Are you just hearing me now? Can you see my screen? No, this is really, I don't know. This is really sad. This is sad, really. I don't know what to do now. Where is it? Let's stop the video. Can you hear me now? Can anybody hear me, please?
Yes, we can hear you now. I think you can do without the video.
Yes, I'm switching off the camera already. So where's the screen I'm sharing just now?
It's just click on share screen.
Go back to here.
No, share first.
I think so.
Share.
Where?
Right. The purpose.
There's in here. Can you see the screen now, gentlemen and ladies?
Yes, please.
Can you see the screen? Okay, fine. I'll be jumping a lot now, really, because the network is really bad. Sorry about that, not my fault. Despite the fact we're even using Starlink internet here, there's still a problem. I think we are really trapped in this. Okay, please, you are free to scan the QR code or the data from the time show the video. So everything is being pushed to the back end, what we call the cloud platform, for further processing using AI. So you may wish to scan, or you can follow the link so you can see the data. It shows you trend, graphs, and so on and so forth. It shows you the volume of the tank, the temperature, and so on and so forth. So the oil and gas chain refers to the entire process of exploration, extraction, transportation. I've already mentioned that. So we're talking about the upstream, midstream, and downstream. So basically, my presentation will be more of practical approach using indigenous technology. And it is my belief that people will understand it better, the concept of AI IoT, when they see actually the practical application of this. So we're looking at the downstream, refining and distribution as well, midstream transportation. How do you track your tankers from the point of purchase to the final point of supply, and so on and so forth, using indigenous technology, which involves AI and IoT. So what are the situation analysis? I'll make this very, very fast. Today we have the concept of digital oil field. This encompasses applying technology end-to-end to run all the operations to do with petroleum extraction up to the petroleum distribution. That is from your upstream up to your downstream. Now, we know some of the challenges we are having in Nigeria. Recall, NNPC is to spend 360 million on organic cleanup. This is as far back as 2020. So the big question is there a way that would have been prevented? I mean, how could that environmental disaster could have happened? Wasn't it possible to have applied technology that will act as an early warning system, to notify when there's oil spillage before it really gets out of hand? Other one is the pipeline also, where we have vandalism of the pipeline. Simply put, oil bunkering. Now, IT is a pervasive technology. It is an enabler, and it is a core industry as well. So big question is there no way we can apply IT? I mean, let me put it the other way around. Is there no way we can apply artificial intelligence of things to solve this problem of pipeline vandalism, oil bunkering? Absolutely. So these are some of the areas we'll be looking how we can apply also this technology to solve our problem. And I believe that some of the industry players, both the regulators, maybe coming from NNPC and other value verticals of the oil and gas industry, I believe they should be part of this lecture and give you how some of these technologies can be applied, without human intervention to solve some of the bigger challenges we have, which is the oil bunkering. Now, we're talking about JTF on the pipeline, but these are human beings. So the big question, should we solely trust human beings to help us, reduce this issue of oil bunkering, or do we trust pure technology end to end? You know, for me, I believe in the later, where we can trust the technology end to end. So I'll move on very, very fast. Today we're talking about AI and IoT, but it is important to note that technology is very, very dynamic and with very high rate of diffusion. So just yesterday is IoT, just yesterday is AI, but today there's a convergence between Internet of Things and artificial intelligence. Just as I mentioned earlier, any AI platform is driven by three factors.
Ladies and gentlemen, sincerely apologize. Sincerely apologize for what's happening. We believe that our speaker will come back on the call shortly. While we await our speaker coming back, we'd like to recognize the presence of the program's chair 2 on the call, Dr. Yetunde Oladita. And Dr. Yetunde, a very good evening to you, ma'am. Oh, Dr. Yetunde. Okay, we also like to most respectfully welcome the presence of our treasurer on the call, Mrs. Nana Rimtim. A warm evening to you. Confirm you can hear me.
Good evening, Akwan. How are you doing? Good evening, everyone. I hope our evening is going well.
Yeah, it is. Thank you so much, ma, for joining the call. We still await the presence of our speaker who has a poor network at his end. All our student members, thank you for joining us, and he will join us shortly. Just give us a few minutes. He's trying to change network. I can see that Nile University has quite a lot of students here. Welcome all student members from Nile University. I can also see Futmina here present. Welcome all students from Futmina. Please, student members, we kindly appeal that you rename your device with your name first, and then your school name. Uni Abuja student, welcome. Bayes University student, welcome. ABTU student, welcome. AUST students, welcome. BUK students, welcome. Futmina students, welcome. University of Maiduguri students, welcome. So please rename your device properly, your name first, thereafter the name of your university. Once again, welcome to all of our students, members. We still await Dr. Agu Collins Agu, the founder and chief technology officer of TD4PIA Hard Tech Hub Nigeria and the pioneer director of research and development NITA.
Hello, everybody. Can you hear me once more?
Yes, your voice is louder and clearer now.
Well, gentlemen, actually, it's very, very sad that this is happening because I'm joining you from Kuje here, Kuje Area Council, the TD for Pahate Corp. So most of the time, the connectivity here is actually a very big challenge. So could you kindly tell me when you had me last, please? When did we had me last when? Let me go back very fast.
Sir, probably the first page, your first page, your introduction.
I'm not getting you. Do you mean first page?
Yes, your introduction, yeah.
So am I supposed to go back now to first page?
Yes, sir. But you could summarize it so that it could be faster and so that you have like 20 minutes left.
20 minutes left will not do anything, gentlemen. That's it. I can't do anything 20 minutes. I have a slide. I have quite a number of slides here.
Okay, let's just start, sir.
Okay, fine. So can you do this for me? Let me connect. I'm trying to share my screen. Okay. So, can you see my screen now, all of you, please?
Very well, sir.
Yes, we are seeing.
Okay. I will just skip. I've mentioned about some of the products of the hub. I'll be sharing the slide later for some of you. The primary driver of digital technology. Were you able to watch the video? Were people able to watch the video, please?
No, network did not allow us to do it.
And monitoring how water is coming out. And then this is the data acquisition platform. As you can see, fully functional. The solar panel and everything here. Okay, I hope you can hear me. So what I just showed was remote monitoring of a reservoir. So we're talking about oil and gas now. So that reservoir could be that reservoir could be your jetty, it could be your diesel tank, but in lieu of diesel or crude, we're using water here So what you do for me now is that, please, there's a case study here. If you can scan the QR code or go through the link, you can actually, the link will take you to where the data is going. The link will take you to the data, all the whole data being acquired, where it is pushed to. So just for you to have an idea of where the data, what kind of data, the temperature data, the volume of the tank, and so on and so forth. Everything, even the location of the tank, everything is pushed to the broker platform for further processing. I think I will not dwell more on the introduction because I've already gone through all this already. Basically, so I will just push straight to the situation analysis. We're all aware of the Ogoni pollution at the Ogoni land it's being cleaned up right now. I think 360 million. So the big question is, was it really possible for us to have introduced a technology that would have acted as an early warning system, to sense the emission of hydrocarbon gases to alert the authority? Why did we have to leave that land to be so degraded over years? So I believe that with the introduction of AI and IoT, that problem would have been solved. That environmental degradation and catastrophe wouldn't have happened. That is the importance of artificial intelligence of things. We would have deployed some sensors through IoT and constant data processing at a back end using our AI. Would have been able to tell us the concentration of any gas being emitted there, then the location of the spillage, and then if possible even telling us how much spillage is happening real time. So I'll move very, very fast anyway, please, because I have 20 minutes, I'm told. So the advent of AI and IoT has revolutionized operations. Just as I mentioned, the IoT helps you to do what they call data acquisition, and then with acquired data can be fed into an AI system. Why? Because three main factors are drivers of AI. First is your robust data sets. The second one is your algorithm. Then the third one is your hardware, where that's the compute factor comes in. However, the role of IoT is the data acquisition. Reliable data that is fed into an AI system, because in computer science, it is garbage in, garbage out. So the big question is, how do you get that robust data set to feed into an AI system to give you the necessary prediction and output? Now, the Internet of Things was coined by Kevin Ashton, working for Procter and Gamble's. So they were looking at the distribution chain of the company, and they wanted to have a remote visualization of how the whole products are distributed using RFID technology, across their whole retail outlets. So that's where the IoT got coined up by him. And the essence of the IoT is basically for remote visualization or visibility, where you can actually see what is happening at the tail end of your supply chain, and also generate data for insight. Now they were using RFID technology then, to help them market their product. RFID is a radio frequency identification. It falls under the AIDC, auto ID and data capture technology. The same technology is applied at oil and gas upstream for monitoring of tools, monitoring of machine equipment, and so on and so forth. So I'll just move fast on this one. So IoT is also one of the pillars of the fourth industrial revolution. So let's look at the IoT map. So it's made up, I use the word PPTT, that's people, process, and technology. Things could be inanimate objects, animate objects, that's your people. Even you talking to me and seated there, you're also part of the IoT ecosystem, because your phone can actually tell your location. Your phone can actually tell us how many steps. If you're running, if you're walking, everything can be pushed for analytics. Then data comes in as well. Data acquisition comes in. Then data is processed. So all this helps us to make some decisions which are critical to many management processes, and so on and so forth. Then I use the word 4C technology for IoT. That's where the computation comes in: control, connectivity, and cloud. Your control is the embedded system. Now, the big question is, how do you acquire temperature data remotely, humidity data, the kind of gas being emitted? Is it a sulfur dioxide? Is it nitrogen oxide? Or so on and so forth. So it is through the embedded programming using your microcontrollers, FPGA, connecting the sensor helps you acquire that. Then the computation is, how do you develop the algorithms or the necessary instructions that makes the system intelligent? Because naturally, any microcontroller, microprocessor is dumb. It's a human being that will create the algorithm, create the code that makes it intelligent at the end of the day. So that is where the software comes in, firmware, and driving the computation. The same thing with the cloud. All this data, where is it pushed to? So it's pushed to the cloud, where the AI comes in now, to do processing of the data, and then gives what they call the data presentation for subsequent decision making. Connectivity is key. Those days we're talking about CCNA, Cisco certified. Nowadays it's more of a who are we, because Huawei they have sold Cisco more than 7 times. However, the connectivity here is talking about the embedded connectivity, things to do with your various communication protocols like your SPI, I2C, one-wire protocols, and so on and so forth. So I'll move fast on this here. I'll move fast because of the time. So we're looking at oil and gas, and we also have the concept of industrial internet. So what it does for us, that, as I mentioned, gives us visibility, as you can see. It gives us here visibility, cost reduction, data. With data you can plan, and so on and so forth. Then now today's topic is the artificial intelligence of things. So I want us to take a closer look at this very diagram. So first of all, have things. As I mentioned, things can be animate or inanimate objects. Then we have the internet. I mean, these are the main components of the 3 cycles. Then we have the artificial intelligence. Now, the convergence about things and internet gives you the IoT, Internet of Things. Then the convergence of things and artificial intelligence gives you intelligent things. And then also gives you, subsequent gives intelligent internet. So everything comes at an intersection that is called artificial intelligence of things. So basically, you need a communication line for AI, artificial intelligence of things to work. You need a data acquisition platform. You also need a processing backend or a processing platform where the whole data can be turned into a meaningful insight. Now, let's look at the challenges in midstream and downstream oil and gas. We have the challenges involved with the exploration itself. How do I sense my equipment? How do I know the health of my machine? How do I know if my drilling equipment is about to break down? How do I know what is making it to break down so I could prepare the necessary workforce and tools for repair to reduce downtime? The next is logistics now. How do I monitor my petroleum product being transported from point A to point B? How do I know if the driver has stopped his location? You know, up to the filling stations. The petrol is in my reservoir, or what we call the system. How do I know how much quantity is there? Or the other way around is, how will NNPC monitor people that are hoarding fuel now? I have a filling station, the reservoir is under my filling station. How will NNPC know if I'm hoarding fuel or if I'm not hoarding? That is where the IoT comes in, that is where the AI comes in, and so on and so forth. So we'll be looking at them one by one. So let's look at the sub-field application of AI in oil and gas. So I'm getting deeper now to our topic. I was trying to lay the foundation for discussion. I mentioned already fleet monitoring, that's logistics comes in. I mentioned about pipeline monitoring, leak detection, and so on and so forth. Now, our primary export in Nigeria, our major export is oil and gas. Now, we have the issue of bunkering that happens on a daily basis. Is there a way we can use AIOT, that's artificial intelligence of things, to fight it? Is there a way we can deploy some electro-optic systems that can monitor the pipelines 24 hours using AI, and they're using ML, machine learning, to train the system, to detect what they call the TPIs, third-party interference, and then backhaul all the information to a central, what they call command and control center, that can alert the JTF, give them the coordinates, or send a reconnaissance mission of drones to go and get a proper picture of there and see what is happening. Because it's not enough to put JTF online. It's good to actually apply technology, and the technology only gives them the coordinate to act, and everything is documented. And of course, reservoir is very important, transportation, the jetties, tanks, and so on and so forth. I'll be demonstrating some of the applications or solutions we have here for remote tank monitoring. There are also video materials. I'm trying to be very, very fast. I mentioned about monitoring of temperature, humidity, and so on and so forth. Pipeline leakage can also be monitored using various sensors. So I'll be taking you now to a solution we developed here in Nigeria at the hub, remote monitoring of reservoirs. So I will play it with the video. So we developed what we call a smart tank. It's an AIoT smart fluid monitoring system. So this system can be scaled up to any size. So it can be deployed to the jetty where the big ship tankers are loading crude or loading other petroleum products. It can be used for your diesel, to monitor your diesel. It can be used for the LPG. So let me play the video. Let me play the video fast here. So this is the tank right here in Kuche. So this is our start tank. That's the artificial intelligence of things, smart liquid monitoring system. We all know the cost of energy resources now, the cost of diesel, PMS, AGU, and so on and so forth. So the big question is that how do you monitor utilization of your diesel while you're not at home or while you're not at factory? So TD for Power, we have come up with what we call the dark tank. It's an approved supply and solar panel. I want to point out some of the new designs we have added here. So if you come closer, you can see there's a mesh. So with that mesh, you cannot siphon diesel from here. So that's one of the protection against spillway. And then it comes with this whole system, solar panel. So it comes with the solar panel here, this autonomous energy system. And then it comes with our box, the center of intelligence, and you can see the sensor. And all the massive sensors are here. Then if I open up the box here, it comes with our world famous data board. So this is actually the brain that controls it, designed by TD45. Besides, I can see the sensor here. That senses the fuel level. So you can know utilization real time of your diesel. Like if you have remote operation, maybe thousands of kilometers, and we can actually monitor what supply is going out, the supply, everything is automated. And then this could be plugged into a smart contract system using blockchain. What does it translate to? If you place an order, you don't need to ask somebody to actually tell you how much has been supplied. So this very system automatically detects how much is supplied and you can pay the person straight. Absolutely. So these are media and TD45. So I will stop here while we try to show you the interface. There's a mobile app where you can view all this, have the data. Okay, fine. Just to add a little bit. So the solution you're looking at here is indigenously developed. It combines Internet of Things and artificial intelligence. So the Internet of Things keeps you the volume of the tank, gets the temperature of the tank, and other parameters. Then the AI component now is what happens at the back end, where it processes the data, knows when to request for new petroleum product, knows the volume of a new delivery. So you don't need to ask somebody to tell you how much was supplied and so on and so forth. Why this is important is that this can be scaled up, to our export operations. All these big tankers that come in, take crude, people say they don't know how they came in. With this system now introduced, they can remotely monitor all the discharge going on. How much crude is entering a ship, everything can be related to a central dashboard. Everything can be transparent. So that is the power of artificial intelligence of things. So again, we are talking about environmental degradation and emission. So the big question is, if you look at the petroleum value chain, the upstream, midstream, okay, let me say the upstream now. Now, there's what they call environmental set standard, minimum standard of environmental, minimum environmental standards. We have a government agency called NISRIA under the Ministry of Environment. They're in charge of environmental standards. So the big question is, most of these international oil companies, who monitors how much emission that is being given out? Now, who matches it against the set standard? For me, I think the answer is basically nobody, because you cannot monitor what you cannot see or feel or smell. So that is where the artificial intelligence of things comes in. So what you're looking at right now is an emission monitoring system also developed at TD4Pi Hub here, in line with the philosophy of indigenous technology or local content. And again, it is solar powered. So the issue of energy now is solved completely. So you have a Stevenson enclosure where you can put your various gas sensors. You can put your sulfur dioxide, nitrogen oxide, and so on and so forth. And then the whole data can be related to an AI platform for processing and for data insight. So I'll play a little bit of video of the presentation. So this actually can be deployed across all operations. What it does for us is that it acts as an early warning system against oil spillage. So once oil is spilled, hydrocarbon gases are released. So these very sensors, if they deploy as a network of sensors in Niger Delta or areas of petroleum extraction, with their GPS coordinate known, then we can easily identify where there's a spillage. You can know the quantity based on the gas concentration. You can start acting very, very fast. And because data can be democratized, you cannot hide it. We can share the data to third parties that you can't hide when there's a spillage going on and so on and so forth. So again, this is made in Nigeria. This could be deployed, and basically this gives us sustainability because we can scale it up, we can adapt it, we can customize it, as the need arises. So I will not play this video now because of time. I'll go to the next. Again, is the environment now. Soil degradation. How do you monitor soil? So we also created a system. If you notice, all the system also based on energy, on the solar energy. Because without energy system, these technologies don't work. So we make sure we have energy harvesters on all the solutions that are going out there. So if you're talking about the oil and gas, again, upstream, where we have exploration going on, drilling and so on, sometimes there could be pollution of the soil and water. So who monitors the soil? Who monitors the river there to know when the concentration is more than, is more than as permitted by NISRIA or the environmental regulators in Nigeria. So over there on this tree, you can see a sensor here. This sensor monitors the pH of the soil. Monitors the pH of the soil, monitors the nitrogen content, potassium content. So we can actually apply other sensors so you can monitor other parameters of the soil. So this can be relayed. So I would use Ogoniland as a case study now. If we had sensors like this across Ogoniland, when this spillage was happening, they would have reported all the incidences far many years ago. There would have been no cover-up, absolutely. So that is where the artificial intelligence of things comes in. This very, very strategic technology that can be applied to solve some of these pressing challenges we have with oil and gas. So that body you're looking at that is called Udeneboard, also developed at TD4Pi. It's a data acquisition platform based on IoT. So I will skip that due to time. So again, we mentioned so many things about oil bunkering now, pipeline vandalism. So there was a project we came up with, also based on AI. So we were proposing what they call electro-optic system, non-invasive method. We don't want to put sensors on the pipeline. So that comes on the midstream now, talking about the midstream oil and gas, the midstream now, okay? So we propose an AI-powered camera that can do image recognition, what they call the DRI, image detection, image recognition, image identification. So when this information is fed to an AI system, it can detect what we call the TPI, third-party interferences. That's illegal interferences, people coming to the pipeline, people bedding down, trying to drill. All this data is relayed real-time through maybe a large ComSat to one satellite. We have a communication satellite managed by Nigeria Communication Satellite Limited, NatComSat. I used to work there before going to NIDA from where I retired. So they have a KA band, KU band, where this data can be streamed real time to, again, your command and control center. Everything can be monitored. Your jetty, can monitor from your jetty, from your pipeline. So I will just go through. So this is what we have in TD for Pi Hub. So this is like a prototype we developed in TD for Pi Hub. So you can see the camera here. You can see the LED light here. You can see the KU band from NatComSat. So you can have real image being streamed. And because the system is already trained using machine learning, you can detect easily who is puncturing which pipe at what time. And guess what? These coordinates can be given to the JTF now to act. And this information can be sent to a fourth party or third party where you can actually see what is happening. So the issue of, opacity is reduced. Opacity is reduced. Everything becomes very, very transparent. So these are actually the hardware components. Let me use the word, the architecture of what we call the dark tower. The dark tower is acronym for data acquisition tower. It's actually a smart tower that can acquire images, process the image, and then give you an insight, tell you what is happening. So this is our design we did. Actually, this is the first time I'm sharing this very architecture publicly, but I feel that people may be interested or can work together there to solve some of the Nigerian problem. So application example is what we want to show you now, monitor and surveillance. So this is a real camera, military grade PTZ, pan tilt zoom. So this camera can detect human beings 40 kilometers. Then it can detect vehicles at 55 kilometers. Then it sees at night. So there's a difference between thermal camera and infrared. Most Nigerian security applications or security installations, they use infrared. So most of these things should be using thermal camera. Thermal camera sees far, far more than infrared. So I'll move fast on this. And it prevents the post-digital oil field is it can monitor and maintain critical oil assets, downtime operation. Okay, let me just move here. So these are some of the pictures. So you can see down here the number of a ship many, many kilometers away at night. It's able to capture it. So the same system can be deployed across the Niger Delta. You use solar energy. It is plugged to NatComSat 1R satellite. It is trained using ML, which is a subset of AI. Then you have the IoT that can acquire the environmental data like the oil spillage, the gas, whatever. All this can be pushed to a backend to be processed. And then data insight can be given as well. So it can apply for illegal bunkering detection, as I mentioned. Real-time surveillance, of course. You can actually see what is happening there real time. Then as human beings, we may not always be aware, but then comes the machine learning and AI that will help us do the necessary predictions and so on. And so environmental monitor, it does oil spillage detection and so many things it does. So I'll just move very, very fast. So I mentioned about the environmental monitoring system. So this is an overview of a system which is also based on AIOT, where you can have all these blue dots are what they call sensors, as I mentioned. So in Niger Delta, you can have this sensor network deployed, 1,001 of them deployed across the whole creek. So this sensor network now has an IoT component that senses the gases. It tells us what gas, tells us what concentration, it tells us the location. All the whole information can be processed. Some can be processed what they call in situ, what we call edge computing. Some of the information can be processed, in situ, that is on the spot, decisions taken, while some can be pushed to a back end for further analytics, maybe an AI system and so on and so forth. And then all this information is related to your mobile device through the internet. So you can connect it to your desktop computer, you can also connect it to your mobile device. And everybody will actually see what is happening. Everybody sees it, nothing can be hidden. So this can be deployed to monitor our waterways against oil pollution, you can monitor our land as well, can monitor our air against air pollution as well. Now, in TD for Power, as I mentioned, so we came up with this system for remote tank monitoring. So we're using a plastic tank, your common water tank. So you can see the sensor up here. This is the sensor, non-invasive ultrasonic sensor. I wouldn't want to go into full details here. So we were working together with a company called ByteWorks. It's a very, very powerful IT company in Nigeria. They've been supporting us on this very project. So more people can actually join us for us to see how we can come up with all these solutions that are AI-based, to help us solve some of these problems in the oil and gas value chain. Then, as I mentioned, renewable energy system is very, very important. So we also come up with energy systems that are reliable and renewable as well. So this is an example of an energy system we're working on, which is based on 12 volts. And then, of course, here takes us to the Unity board. So all these examples I've given, all are being powered by a board called Unity board. So this Unity board was developed here in the hub. It was designed. I'm the principal designer with an input from Professor Isali Ibrahim Pantami as well. Though right now we have other new versions of it, which we have, so these are some of the specification of the board. I'm moving very fast on this because of time. Then this is the block diagram of the board. So you have to pay attention here. You can see the communication. It has a GSM, it has a USB, it has a Bluetooth, it has a Wi-Fi. So this forms multiple communication redundancy. As I mentioned, connectivity is key. If I acquire sensor data, where do I push it to? So this board lets you push it. And then the gas sensor is, as you can see, the digital thermometer is there, and so on and so forth. Quite a lot of functions. I could talk on this. So the big question is, what is so special about this very platform we have created, the AIOT platform? So these are the special things we have. Most of the boards out there, they don't have any deep harvesters. All the boards, I can plug in a solar panel, it will charge your battery and it will power it. So that gives you autonomous power system, and so on and so forth. So these are some of the advantages our own system created here we have. That's the IoT enablement platform to solve, enablement platform for remote monitoring. So these are other specifications. I'll move fast on this. This is the competitive matrix feed application. And this is the presentation of the board to the public by the former Minister of Communication, Isali Ibrahim Pantami. I will jump this very, very fast. So it's a government-recognized platform. This is in GITEX too. The board was launched in GITEX, Dubai, 2019. And then this is also in the hub, other application. This is for remote monitoring. As you can see, you have the battery there. That's the board with the charge controller, external charge controller now. So it can be used for monitoring of, as I mentioned, maybe the waterways, your air, what they call your emission, or what they call your air quality, if I can put it, and various areas of application, even beyond oil and gas. So that's the patent, that's the award, and then that's the conclusion. I have to be very fast on this. So please, thank you very much. And let me take some questions. I'm sorry about the network, really. I actually went very, very far with this presentation, only to be told that you had me last on first slide. I'm quite sorry about that. Okay, so I will share the presentation with you people. Of course, it has to come through the management of this very society, and then we can see how we can partner in some of these things. So thank you very much, and the floor is open for questions. Thank you. Yeah,
thank you, Dr. Collins Ago, for that very, very swift presentation on all of the amazing things done by your organization. Ladies and gentlemen, it's time for question and answers. We know that our speaker was battling with time, but however, if you have any questions now, he will take time to speak on any slide you may want to ask about. So please, I would like you to raise your hands or you drop a chat in the chat box and I'll read the questions to him. So who has a question to ask? I would say one student member will ask a question. If there's no questions, one YP will ask a question. And then probably one senior member will ask a question. We'd like to hear from all of our participants online. For students, now university, any question? Okay, I see the hands up. Dr. Malami Mohammed. Sir, please go ahead with your question, please. You can unmute your mic, sir.
Okay, good evening. Good evening, leadership of SPE. Good evening, doctor. My question is around the sensors. Many a times we talked about deploying sensors for surveillance and whatnot. But the issue is what are the economics of these sensors? Because by procuring these sensors, you are adding additional cost to your cost of your project. And again, if, for instance, you want to deploy these sensors to, let's say, 5,000 kilometers of pipeline, how many sensors do you want to deploy and at what cost? And again, the second thing is, I don't know whether in your approach, whether you have developed maybe an algorithm that will rather detect before the occurrence of any attack on the pipeline, because mostly what we have seen in the industry is merely a reactive kind of response. So reactive is good, but then again, if you don't have a quick turnaround or a quick early response, to the signal, then all effort is just somehow, because at the end of the day, before you're able to attend to the issue, you may have lost a lot of money and maybe put a huge investment. So I don't know if Dr. Ogo can please respond to this. So whether if they have any algorithm that can even detect before any attack on any pipeline, because seriously, this is one of the major issues we're having in the industry as of today, especially from Nigeria. We're losing a lot of money due to the pipeline vandalism, sabotage, and whatnot. So please, I'd like you to put some comment around this. Thank you so much.
Okay, thank you, Doc. This is an interesting question. Very, very excited to say that. So I'm purposely displaying this very slide. As I mentioned in the past, I think I may have to open up more. During Jonathan's regime, I was a member of ad hoc committee on pipeline vandalism prevention and coup prevention. I think it was chaired by Omoborio. Is it Omoborio, the Ondo State governor, Labour Party governor? Then he chaired it, and Uduaga was his vice. So over in that very committee, I proposed for them to use fiber optic technology, optical fiber, which used for communication. It can also use to monitor interference along the pipeline, up to plus minus 10 meters precision. You can monitor both ways, X, Y, Z, 10 meters precision. However, that was not, that could be capital intensive. It was not adopted. I know how Nigeria is. But right now, the solution we are proposing right now is what they call electro-optic system. Electro-optic system is an AI-powered camera. I want you to listen carefully, sir. It's an AI-powered camera that can see up to 40 kilometers. It detects human being. Look at it, DRI. Detection, recognition, identification. It can do that for a human being 40 kilometers away. It can do that for a vehicle or equipment 55 kilometers away. Meaning that if I have a system deployed, for example, let me use the example, maybe a float station. Let's call it a float station, okay? That means I can drop a system to look eastward, drop another system to look westward. So by the time you add everything, it can be having hundreds of kilometers up to 200 kilometers. Now, the system is trained using machine learning to detect what they call TPI, third-party interference. In other words, oil bunkering. You train the system to detect false positive, false negative. If somebody is crossing the pipeline, for example, the person is not bunkering, the system should not raise an alarm. So this system is trained using artificial intelligence. Okay? So when it is trained now, it knows when you're bending down to bunker, how long you have been there. And this information now is related to the GTF. So there's an algorithm that is there for this system to detect all illegal, and even legal, both illegal and legal. So to tell you somebody is bending down, somebody is trying to drill, everything, can be detected basically using this electro-optic system. Now talking about sensors, well, let me put it now. This very system will be fenced. It will be like just as name implies, as dark tower. The dark tower is actually data acquisition tower. Let me go back again. Data acquisition, meaning that this system we're looking at will be fenced. So as before you can attack this system, that means you have to come closer to the fence most of the time. Then it has additional cameras that can monitor its perimeter as well. Using ML, AI, it can detect what is happening. And then it is real-time video streaming, as I mentioned, using KA band. Look at the KA band. You can use KA band or KU band of NatComSat 1R satellite. It is a Nigerian satellite under the Federal Ministry of Communications, Innovation and Digital Economy. Okay, they can use to have real-time image streaming both day and night. Okay, to the control and command, central control and command center. Okay, so you can have this maybe up to 10 of them as a network, looking across all the whole pipeline. Then they can have additional sensors attached to it to monitor the environment now. So you can do what they call a emission monitoring system to monitor hydrocarbon gases that senses when there's oil spillage, to monitor sulfur dioxide, to monitor nitrogen oxide, all these harmful gases, depending on the sensor you're putting in there, you can monitor it. Now, talking about the cost, let me give you a typical example of a sensor now. There's a sensor I have here that monitors what they call VOC, volatile organic compound. Well, I'm not a businessman, so I'm sorry if I'm spoiling business for anybody now. That sensor costs less than $10. So what does it monitor? It monitors your volatile organic compounds. It monitors your humidity. It monitors your pressure. It monitors your temperature. It monitors your altitude. It contains an altimeter that monitors the sea height above sea level. So just a sensor costing $10 can monitor 5 different parameters. So the issue of cost, if you do what they call the cost-benefit analysis, the issue of cost is not even up for discussion, to be honest with you. How much does this camera cost? Let me put this camera example. How much does this very camera cost for military grade? This camera should be less than even $3,000, even with the profit involved in it. I'm sorry, I have to be mentioning things because I want a problem to be solved in Nigeria. All these problems are solvable if we're serious about it. So this camera now is less than $3,000. So if you buy 2 east-west, $6,000 just for camera, how much is it to build a tower, fancy, put other sensors? How much is it to get a KAKU band and everything? Or if you don't want the KAKU band, you can use the Starlink internet. But we believe in local content. So it's better to use the KAKU band of Natcomsat. Or you can use the Starlink internet, which I wouldn't go for anyway, for security reasons and for patriotism and for local content policy. I don't know if I've answered your question. So the cost implication is not much compared to the problem this is solving. And because it's an electro-optic system, there's nothing you can cut. Fiber can be cut, but the electro-optic system, nothing you can cut because it's using pure optics. It's just looking ahead. Just the way you have your satellites from space, military satellites that can do remote sensing of Earth, the same principles we're approaching now, we're applying here. The camera can see 70 kilometers or even more. Okay, it's far from you, so you can't do anything to it. So before you approach it, it sees you already because there'll be one called the scout camera. There's what they call the scout camera. The scout camera is a scanning one that keeps going 360 degrees. Whenever I see something that is not correct, it pushes the real camera, the major camera, to pick it up, analyze the data. Then this data can be fed to JTF or to reconnaissance missions, like to drones. Can feed those GPS coordinates to drones. Drones can take off, go to the spot, take good picture of that, or maybe try to neutralize them or intercept them. Thank you very much. The corporates. I hope you guys heard my voice.
We did.
Yes.
Okay, I'm already scared talking to myself for long.
Okay, Dr. Malami, please confirm you've gotten a full response to your question, sir. Okay, I believe Dr. Malami, his silence means yes, he's gotten a full response.
Maybe
okay.
Offline. Who knows?
Okay, so Mogaji Muhammad is asking how to get the slides. The slides will be sent to the section and the section will communicate it to all of the attendees. Thank you so much, sir. I think at this juncture, we do not have any other questions. Thank you. Please, can we give our speakers some virtual applause?
Okay,
whose hands is up? Oh, we have 2 hands up. Oh, sorry, sir. Section chief, sorry for that. Please, let's allow section chief to ask his question, sir.
Yes, thank you. Can you hear me? I can confirm you can hear me.
I can hear you,
loud
sir.
And clear, loud and clear.
Okay, thank you, Dr. Agu. Quite an interesting presentation, especially for the amount of solution committee to provide. My question would be, have we done a pilot of these? Has it been deployed? Even if it's just a pilot of it, has that happened?
Okay, I'm responding now. I believe that you mean the pilot of the electro-optic system. That's what we call the dark tower. The pilot has not been done.
Yes,
the pilot has not been done. And I want to use this opportunity to actually, I believe that this very society can actually drive for the pilot to be done because you represent the petroleum industry, the whole value chain. Okay, but we already have the architecture of the system. We have the full architecture. So the architecture is having like 70% of the job done already. Absolutely. We have tested it using our own improvised cameras here.
Where are you?
Sorry?
At what TRL level is this?
I cannot hear you well, please. Can you repeat yourself?
Can you hear me?
I can hear you, yes.
I'm talking about the technology readiness level. What level is it? 4, 5? stick. Because why I'm asking that question, the Triple Helix Nigeria, we have kind of like a program where solutions like this we try to push them on board, and then we could have a partnership with XPP and the Triple Helix CP where we come in to find a common ground, because we need solutions like these, indigenous solutions like these that are quite innovative to get into the market and then solve topical problems. So maybe we'll engage offline and then take this offline. Thank you. I'll reach out.
Okay, thank you so much. Please, please, you're welcome. Just to react very fast. As I mentioned, I intentionally did this very lecture or presentation infusing local content, which is very, very important, because I don't believe in just grammar, nothing happens. So we wanted to involve field application of indigenous technology. That is essence, hoping that people can come in partnership, and they're hoping that the government can use your platform as a society even to deploy a pilot, for goodness sake. Can we just deploy like maybe 2, 3, 4 pilots, and do the adaptation, and they'll replicate it across board? This creates visibility end to end, gives you 360 visibility of the whole operations in the whole oil and gas value chain. For the explorer, oil is leaving the oil well, as crude is leaving the oil well, we'll put our flow meter there. And through AIOT, you can have a dashboard where you see the whole thing coming. It's so sad as a country that you can hardly know how much we export a day. It shouldn't be. This kind of technology can make it. You can open up your dashboard and see everything happening in real life. All the whole oil field, the Christmas trees, install the IoT-based flow meters. Everything is being pushed at the back end with AI doing analytics. Everything becomes transparent. So this solution is from end to end, from your upstream up to your downstream. Both the emission monitoring system, both the environmental monitoring system, and several others. I just showed you a board we developed, the Unity board. We also have within a board. All these enablement platform that has been tested and it is 100% working. The design is also, everything is made in the hub here in Kuche, and it can be customized or adapted for further applications. Thank you very much.
Thank you. Akpan, can you hear me?
Yes, sir.
We should be able to have a courtesy visit to Dr. Colin Agu's right? So let's pencil that. If it's open to that, let's pencil it for next
I'm
year.
open for that. I'm open. Immediately open.
Thank you.
Okay.
Akpan, over to you.
This not a section change. Zubair, I think I saw your hands up. Do you want to ask a question? Are you still on the call? Okay, I think Zubair has left the meet. Okay, Zubair Usman, please. Your hands are up. Can you ask a question, please?
Thank you. Hey, good evening, everyone. Okay, my question is on data security and privacy. This platform you for this project, just want to know, is it an indigenous platform or the conventional platform for cloud?
I'm not hearing you well.
Please, can you hear me?
Can somebody repeat your question, please? I can hardly hear him. I couldn't hear him at all.
Please be more audible, Zubair.
Asking if this is an indigenous database platform used for storing the data, or it is a conventional cloud platform that were used for the project development in terms of security and privacy.
Okay, fine. Let me answer the question. This is an interesting one, because when we think about the data security, it is high on the agenda, especially with very strategic and military installations. Now, let me start with the board. Okay, we have what they call silicon security. That's what they call the PKI chip that is on the board. That's the first layer. So from the point of acquisition of data, we have encryption, what they call the hardware encryption. Okay, before it's even sent to the back end where you can have a further encryption. Now, for you to access our data, maybe through an API, there's what we call the read and write keys. Those keys are also secret keys, that are protected by different algorithms, like maybe 256 AES and so on and so forth. So security there is very, very paramount, starting from the point of acquisition to the point of processing, and then from the APIs, we have protection on that. Now, secondly, is that the data we're acquiring is not more of a personal data. If you look at it, it's more of a technological data to do with operations. We may be little or no human, little or no personal data. But even at that, everything is protected when it comes to data. Why? Because we don't want a situation where we can have a negative stakeholder plugging in there to distort the data. And that is why we also, if you watch the other video that I played on the dark tank, the diesel monitoring, you must have heard me mention about blockchain and smart contract. So all this technology now is used now to increase the integrity of the data being being pushed to the back end, because we don't want it to be to be tampered with without other people knowing about it. So that is where the blockchain technology comes in to protect it. And of course, we'll be ready to partner with other people, maybe the experts in cybersecurity, but they have to be indigenous Nigerian companies, please. Indigenous Nigerian companies can partner with them for further augmentation of data security and so on and so forth. I believe that this should be a kind of a crowd-funded, a crowdsource. Is it crowdsourcing? A crowdsource project where collaborators can come together and try to deliver this very solution, getting experts in different fields. And I see I see this very society as actually championing the cause, and for us to come up with a prototype within the shortest possible time. So the data security is high. Thank you very much.
Thank you. Thank you. Thank you, sir.
Thank you. Thank you. I believe all of the questions are attended to and no more hands raised. Thank you so much, Dr. Ago Collins. Ago, thank you for the time you took to respond to all of the questions. You may stop sharing your slides now, sir. Thank you. So please give Dr. Collins some virtual applause. He's done phenomenal, even with the challenge
So
you had.
where's my face here? Where's my? Okay, I've seen it browser. Okay, start video. Okay, thank you, everybody.
Okay. Thank you. Thank you. Ladies and gentlemen, we continue the event. We're going to wrap up in the next few minutes. Of course, we'd like to announce that if you've not joined SP Abuja section, you should be part of SP Abuja section. There are several professional member benefits like the one you just enjoyed today. And of course, several student members benefits, which I believe you can see on your screen. We also like to announce that for those that are already members, it is time to renew your membership. Membership renewal has started from the September, and of course, on the 31st of this month, if you have not renewed your membership, you will be paying a reinstatement fee. So on the 1st of January 2025, if you've not renewed your membership, you will not be renewing for 69,500 naira. You'll be renewing for 86,500. That's you're paying a reinstatement fee. So please take a screenshot of this slide and call the membership chair so that you can register and renew your membership. Of course, the account details on the screen. Take a screenshot so that I can make your payment. And of course, the membership chairman would respond as soon as he confirms your payment. We are live on all social media platforms: YouTube, Instagram, Facebook, Twitter, formerly called Twitter, now X. And of course, this event and our previous events have been live streamed on YouTube. You can always go back and refresh your memory. We have an event for the young professionals on the 20th of December, 2024 by 12:30 p.m. because it's themed the Knowledge Box. We have graduate students from AMIT and of course a digital transformation management expert who would be giving us a lot of knowledge that day. Please do well by attending the event. Screenshots and register for the event. Ladies and gentlemen, please, we'd like to welcome our program teacher to Dr. Yetunde Oladita as she comes for the closing remark. Please help me welcome her as she does her closing remark, please. Dr. Yetunde, the stage is yours for your closing remark.
Please, can you hear me?
Yeah, loud and clear, loud and clear, loud and clear.
Okay. I'd like to say a big thank you to our resource persons. Personally, I've learned a lot about remote sensing, remote monitoring as regards to the oil and gas industry. Thank you so much for your insightful presentation. I would also like to appreciate as many of us that were able to stay on the call, regardless of the epileptic network. We're able to stay to the end. Thank you so much. For those that worked at the back end to make sure that this program's successful, I would also like to say a big thank you. I'd also like to appreciate the chair for giving me the opportunity for this closing remarks. Thank you so much, and I wish all of you a good night rest. Thank you.
Thank you, Program Street 2. Please keep the camera on because we want to have a screenshot of your beautiful faces, ladies and gentlemen. Please turn on your video cameras. If you're still on the call, please turn on your video cameras. Please, ladies and gentlemen, kindly turn on your video cameras. Kindly turn on your video cameras. Thank you. Thank you. We can see our publicity chair on the call. Oga Adefe Atebe, thank you for joining us.
Good evening, everyone.
We also see an executive on the call, Falulu. Thank you for joining us. I think our diversity and inclusion chair, Farida Denali, on the call. Thank you, ma'am, for joining us. And of course, any other board member I have not seen, probably have skipped. Welcome, welcome, welcome. So, ladies and gentlemen, when I say SP Abuja, you respond with culture of excellence. Culture of excellence with your thumbs up. When I say SP Abuja, you respond with culture of excellence. Please, we are not only 6 on the call, we are about 28 on the call. So please, ladies and gentlemen, please, I kindly appeal that you turn on the video cameras if you would like to feature on our social media posts as a professional that attended this event, please. Thank you, Abubakar Ismail. Thank you, Falulu Malumfashi. Thank you, thank you. I see some places don't have NEPA lights. We're so sorry about that. Just turning on. We have seen your beautiful white dentition when you smile. Okay, so ladies and gentlemen, when I say SP, respond with your thumbs up with culture of excellence. Okay, SP Abuja.
Culture of excellence.
SP Abuja, you're not smiling?
Culture of excellence.
Culture of excellence.
Okay. Okay, thank you so much. We call it a day. I end the call in 5 minutes, just let's walk, and then in 5 minutes we end the call. Thank you.
Come.